Separate and solve the ODE if possible. So this one's a little bit different from the others, and this can happen fairly often in the more complex separation of variable problems, separable equation problems. And so, all right, first thing, this looks very separable, right? I'm going to multiply by the bottom, cosine x is on top, rewriting y prime is dy dx again, equals cosine of x over 9y to the 8th. Oh, I can do better than that. Okay, plus 1. All right, so now we're going to multiply to get the y's on one side, the x's on the other. So multiply by the bottom of the fraction here, I'll end up with 9y to the 8th plus 1, all that times dy equals, multiply by dx, I get cosine dx. Cosine x dx. Next step, apply indefinite integral to both sides. We'll get indefinite integral 9y to the 8th plus 1 dy equals indefinite integral cosine of x dx. All right, so that ends up being, I'm going to start over here, I have enough room. So the 9y to the 8th, well, you do that backwards, the 9 will get absorbed into the exponent, so it's really y to the 9th. Then the plus 1, that's going to be plus y. Again, then constant integration on the other side. The integral of cosine is positive sine, so we'll end up with sine of x. And then there's the constant integration. And that's really all as far as we can go. So this is fairly common when you try and do separable equations for ODEs. Oftentimes you can get rid of the y primes, so you end up with just y's and just x's, but then you get stuck and you can't actually solve. So this is called an implicit solution. Implicit solution. And it means you haven't solved for y by itself on one side. So an explicit solution would be y of x equals, RHS with only x's on it. X variables. I'll say expression. Right, so we can't do that in this case. We can't solve for y all by itself. So instead, we're just going to leave it as is, as an implicit solution, and we can't go any further.